The largest galaxy ever found is so enormous that your mind will most likely struggle to make sense of it. That is not exaggeration. It is the reality of a cosmic giant lying more than 1 billion light-years from Earth, suspended in deep space, wrapped in a faint glow of more stars than anyone could ever count across endless generations. You may feel like you already understand how large the universe can be. You've seen how small Earth looks beside Jupiter. You've heard that more than 1 million Earths could fit inside the Sun. You may even know that the Milky Way stretches roughly 100,000 light-years from side to side. But the moment we look beyond our own galaxy and into the deeper architecture of the universe, those familiar comparisons begin to collapse. Because out there, at the centre of a massive cluster of galaxies, astronomers have found something so vast that even the Milky Way begins to feel small. Its name is IC1101, and to understand why it is so extraordinary, we have to begin much closer to home. If you enjoy having your expectations about the universe completely destroyed, do me a favour and hit that like button and subscribe. It genuinely helps this channel keep bringing you stories like this one, and I appreciate every single one of you. Let's begin. The largest galaxies we know are so enormous that the human mind almost refuses to accept them. This is not because the numbers are difficult, it is because they are too large to fit inside ordinary experience. We're used to distances that belong to human life. A road can be travelled, a mountain can be climbed, an ocean can be crossed. Even the largest things on Earth still feel connected to the scale of our bodies, our journeys, and our history. But the universe does not work on that scale. The universe builds with distances so vast that every comparison begins to feel fragile. Before we can understand the giant waiting for us more than 1 billion light-years away, we have to begin much closer to home, with the sizes we think we already understand. Start with Earth. It feels large because it contains the entire human story. All of history has unfolded here, across its continents, oceans, cities, and mountains. From the ground, Earth feels endless. From orbit, it becomes a blue sphere wrapped in clouds and sunlight. From farther away, it becomes a small bright point in the dark. That is the first lesson of cosmic scale. Something can hold everything familiar and still be almost nothing compared with what surrounds it. Now place Earth beside Jupiter. Suddenly our world begins to shrink. Jupiter is not just a larger planet. It is a giant sphere of storms, pressure, and rolling cloud bands, so wide that entire worlds seem small beside it. More than 1,300 Earths could fit inside Jupiter by volume. Its great red spot, a storm that has lasted for centuries, is large enough to swallow our planet without effort. Beside Jupiter, Earth no longer feels like the centre of the story. It feels like a pebble placed beside a mountain. And yet Jupiter is still only a planet. It does not shine with its own nuclear fire. It moves around an ordinary star in an ordinary solar system. The moment we lift our eyes from planets to stars, Jupiter too begins to shrink. Then there is the Sun. From Earth, it feels overwhelming. It dominates the sky, turns night into morning, warms the oceans, pulls the seasons across the year, and powers almost every living system on this planet. For much of human history, it was natural to treat the Sun as divine, because everything alive seemed to depend on it. The Sun contains about 99.8% of the mass of the entire solar system. More than 1 million Earths could fit inside it. Every planet, moon, asteroid, comet, and ring of dust is part of a system ruled by its gravity. But even here, the imagination has only taken one step, because the Sun is not one of the monsters of the universe. It is not among the largest stars. It is a fairly ordinary star, one among hundreds of billions in the Milky Way alone. The great lamp of our sky is only one grain in a much larger field, and the distances between those grains are where space first becomes truly unsettling. The nearest star beyond our Sun is Proxima Centauri, more than 4 light-years away. Light moves at nearly 300,000 kilometers per second, 186,000 miles, fast enough to circle Earth more than 7 times in a single second. Light from the Moon reaches us in just over 1 second. Light from the Sun takes about 8 minutes. But even at that speed, light from our nearest neighbouring star takes more than 4 years to arrive. That means the closest star to us is not close in any ordinary sense. It is separated from us by a gulf so wide that even the fastest thing in the universe cannot cross it quickly. If the Sun were shrunk to the size of a grain of sand, the next star would not sit a few steps away. It would be far in the distance. That is the architecture of space. Not crowded, not comfortable, not built like anything familiar on Earth. The universe is closer to an immense desert, where the fires are brilliant, but the darkness between them is almost beyond endurance. And yet all those scattered stars separated by oceans of black space belong to something even larger. They belong to a galaxy. Our galaxy, the Milky Way, is not just a loose collection of stars. It is a vast rotating city of light, gas, planets, black holes, and dark matter. It has a bright central region and long spiral arms that curve outward like rivers of starlight. Somewhere inside one of those quieter outer arms sits our Sun, about 26,000 light-years from the galactic centre. It is moving at tremendous speed, yet it still takes roughly 230 million years to complete one orbit around the Milky Way. That number changes the way time feels. A human life is measured in decades. Civilizations rise and fall in thousands of years. But one orbit of the Sun around the galaxy takes hundreds of millions of years. The last time our solar system was near this same part of its galactic path, Earth belonged to a completely different age. This is where scale begins to change completely. A planet feels large, a star feels enormous, but a galaxy feels almost impossible. The Milky Way is about 100,000 light-years across. If a beam of light began at one edge, it would need 100,000 years to reach the other side. During that journey, landscapes on Earth could transform, species could appear and vanish, and human history could pass through all of its known chapters many times over. And still, that light would only have crossed one galaxy. When we look up at a dark sky and see the pale band of the Milky Way, we are not seeing mist. We are looking through the crowded plane of our own galaxy. That faint river of light is the combined glow of stars too numerous and too distant for the human eye to separate. Many of those stars may have planets. Some of those planets may have moons, oceans, frozen plains, or silent histories that will never be known. Our solar system is not the center of that structure. It is one small point inside it. And yet, as overwhelming as the Milky Way is, it is not the universe. For a long time, people thought it might be. The Milky Way was the heavens. It was the great glowing structure across the night, and beyond it there seemed to be only darkness. Early telescopes revealed faint cloudy patches scattered through the sky, but no one knew what they really were. They were called nebulae, a word that simply meant clouds. Some truly were clouds of gas and dust within our own galaxy, but others were far more profound. They were not inside the Milky Way at all. They were galaxies of their own, entire island universes lying far beyond our own. That realization was one of the great turning points in human thought. The Milky Way stopped being the whole cosmos and became one galaxy among many. It was no longer the edge of reality. It was one neighborhood in an immeasurable universe. Beyond it were other galaxies. Beyond those were groups of galaxies, clusters of galaxies, and vast patterns of matter stretching across space like a cosmic web. This is the moment when familiar comparisons begin to fail, because once we understand that galaxies come in many sizes, we also learn that the Milky Way is not the upper limit. Some galaxies are smaller, faint dwarf systems with far fewer stars. Others are larger spirals, broader and brighter than our own. Then there are the giants that live near the centres of rich galaxy clusters, galaxies that have spent billions of years growing by pulling in smaller neighbours, absorbing their stars and spreading outward into enormous halos of faint light. These are not simply bigger versions of the Milky Way. They are different kinds of structures shaped by different histories. A spiral galaxy is ordered and graceful, with arms wrapped around a central region like the design of a great cosmic wheel. A giant elliptical galaxy is smoother, older, and more swollen. Its shape has often been sculpted by repeated mergers, by collisions that erased spiral arms and scattered stars into wider and wider orbits. What remains is not delicate architecture, but accumulated history. At the centre of a galaxy cluster, gravity acts like a deep well. Over billions of years, galaxies drift, interact, lose energy, and fall inward. Some are torn apart before they ever reach the centre. Others merge more directly with the central giant. Their stars do not disappear. They become part of something larger. Layer by layer, encounter by encounter, the central galaxy grows. Among these giants is IC1101, the dominant galaxy near the heart of the Abell 2029 cluster, more than 1 billion light-years from Earth. For years, it has been famous as one of the largest galaxies ever identified. Older descriptions often gave it almost mythical dimensions, as if it stretched cleanly across millions of light-years, with a sharp edge that could be measured like the wall of a building. Modern astronomy is more careful. Its bright central body is smaller than those extreme claims suggest, but its outer halo is still immense, faint, and difficult to define, and that makes it even more fascinating. IC does not end suddenly. It fades. Its stars become thinner and more diffuse until the galaxy begins to blend into the surrounding light of the cluster itself. It is like a great city seen from high above at night, where the bright centre slowly gives way to scattered lights, roads, and distant suburbs until no one can say exactly where the city truly ends. In the same way, the outer regions of a giant galaxy dissolve gradually into intergalactic space. This is why it feels less like a neatly bounded object and more like a continent of light. Its halo may contain stars that were born in smaller galaxies, later stripped away during ancient encounters and folded into the giant's outskirts. Its smooth shape tells of collisions that erased older forms. Its position at the centre of a massive cluster tells us that it grew in the right place, where gravity could keep feeding it across cosmic time. And this is where the real journey begins. The story of the biggest galaxy is not only about size, it is about how the universe builds. It is about what happens when gravity is given enough time, enough matter, and enough emptiness to work with. It is about galaxies falling into galaxies, black holes shaping the hearts of stellar cities, and clusters acting like deep wells, where matter slowly gathers over billions of years. Before we can stand in the shadow of IC1101, we first have to understand this one truth. In the universe, scale is a ladder with no obvious top. Earth leads to Jupiter. Jupiter leads to the Sun. The Sun leads to the Milky Way. The Milky Way leads to galaxy clusters. And somewhere beyond the familiar steps, giants like IC wait in the darkness, reminding us that every time imagination reaches its limit, the cosmos quietly reveals another rung above it. The story of IC1101 does not begin with a dramatic image from a modern space telescope. It begins with a faint blur. On June 19th, 1790, William Herschel, one of the great observers of the night sky, recorded a dim object in the constellation Virgo. Through his telescope, it was only a soft patch of light, one more mysterious shape among many others scattered across the darkness. He could not have known what he was really seeing. He could not have known that the faint glow in his eyepiece was not a nearby cloud inside our own galaxy, but a colossal system of stars lying more than 1 billion light-years away. That is often how discovery begins, not with certainty, but with a question, not with a clear answer, but with something barely visible, waiting for the right tools and the right understanding. At the time Herschel observed it, the universe was still a much smaller place in the human imagination. The Milky Way was not yet understood the way we understand it today. The faint, cloudy objects seen through telescopes were called nebulae, a word that simply meant clouds. Some of them really were clouds of gas and dust, others were star clusters, but many were something far greater, though no one yet knew it. They were galaxies, entire systems beyond the Milky Way, so distant that their light blurred into tiny smudges. IC1101 lived in that uncertainty for a long time. It was seen before it was understood. It was catalogued before anyone could truly measure its distance or grasp its size. To early astronomers, it was simply another faint object in the sky, one more mark in the growing map of the heavens. But the sky often hides its greatest truths in the smallest details. A point of light may be a star, a haze may be a nebula, a blur may be a galaxy larger than anything the mind is ready to imagine. This is one of the most beautiful things about astronomy. The universe reveals itself in layers. First, humanity learned that the wandering lights in the sky were planets. Then it learned that the stars were suns. Then it learned that the Milky Way was not a mist in the sky, but a galaxy made of immense numbers of stars. And after that came the deeper shock. The Milky Way was not alone. When astronomers finally understood that many nebulae were separate galaxies, the scale of reality changed almost overnight. The Milky Way stopped being the whole universe and became one island among many. Those faint patches of light were not small because they were nearby and weak. They were small because they were unimaginably far away. Each one could contain billions of stars. Each one could have its own structure, history, black holes, planets, collisions, and ancient light. In that new universe, IC became something more than a blur. It became a galaxy. And later, as measurements improved, it became clear that it was not an ordinary galaxy at all. It lies near the centre of Abell 2029, a massive galaxy cluster more than 1 billion light-years from Earth. That location matters. A galaxy at the centre of a rich cluster does not live a quiet life. It sits in one of the deepest gravitational regions of its environment, surrounded by other galaxies, hot gas, and dark matter. Over billions of years, that kind of place becomes a gathering point. Gravity does not rush, but it never stops working. Slowly, galaxies move, interact, lose energy, and drift inward. Imagine a vast basin after rain. Water from every slope eventually finds its way toward the lowest point. A galaxy cluster works in a similar way, though on a scale so large that a single movement can take longer than the entire history of life on Earth. The central galaxy lies at the bottom of the gravitational valley. Over cosmic time, matter is drawn toward it. Smaller galaxies pass too close and are stripped apart. Larger ones may merge with it. Stars are pulled loose and scattered into a faint outer glow. What begins as a single galaxy becomes something layered with the remains of many others. This is why it does not look like the Milky Way. A spiral galaxy has a certain elegance. It has a disk, arms, dust lanes, and a sense of rotation that gives it a graceful structure. But repeated mergers disturb that order. They bend orbits, scatter stars, and erase delicate patterns. Over time, the clean spiral form can disappear, replaced by a smoother, rounder, more swollen body of old stars. IC1101 belongs to that family of giant elliptical galaxies. It is not famous because it has beautiful spiral arms. It is famous because it became immense in another way. It grew through accumulation, it expanded through mergers, it developed a vast outer envelope, a faint halo of stars that stretches outward until its boundary becomes difficult to define. It is not like a wheel. It is more like an old empire whose borders have been redrawn so many times that the original shape is almost impossible to recover. This is also why its size has often been misunderstood. Popular descriptions have sometimes presented this galaxy as if it had a simple, fixed diameter, stretching millions of light-years across like a solid object with a clean edge. But giant galaxies are not measured that easily. Their brightness fades gradually. Their outer stars become more diffuse. Around the central galaxy, there can also be intracluster light, a faint glow from stars that no longer belong clearly to any one galaxy. These stars may have been stripped from smaller galaxies during ancient encounters, left wandering through the cluster like sparks from old fires. So the question of where IC1101 ends is not simple. Its bright body can be measured one way. Its faint halo can be traced farther outward. Its surrounding cluster light complicates the boundary even more. That does not make it less impressive, it makes it more interesting. This galaxy is not a neatly bounded island. It is a luminous centre surrounded by fading layers of history. Then there is the core. At the heart, astronomers have found one of its strangest features, a huge, depleted central region. In simple terms, there are fewer stars near the centre than expected. That emptiness is not a sign that the galaxy is uneventful. It may be the scar left behind by some of the most violent processes in galactic evolution. When large galaxies merge, the supermassive black holes in their centres eventually sink toward the middle of the new combined galaxy. They begin orbiting one another, forming a pair. As that pair tightens, it can fling nearby stars outward through gravitational interactions. Over long periods of time, this process can carve stars out of the core, leaving behind a region that looks strangely hollow compared with the surrounding galaxy. In IC1101, that hollowed centre is enormous. It is a clue that the galaxy has likely experienced repeated mergers, each one helping to build its outer mass while also reshaping its inner heart. Growth and removal happen together. The same cosmic collisions that made the galaxy larger may have helped empty its centre. This is what makes it more than a large object. It is a record. Its outer halo tells the story of stars gathered from other systems. Its smooth shape tells of spiral structures erased by ancient collisions. Its depleted core points toward black holes that once danced together in darkness, throwing stars outward as they moved closer. Its position inside Abell 2029 reveals the importance of environment, because a galaxy this large needs more than time. It needs a place where gravity can keep feeding it. Seen this way, the discovery was not a single moment in 1790. That was only the first glimpse. The real discovery unfolded slowly over centuries as astronomy learned how to measure distance, understand galaxies, study clusters, and read the hidden histories written in starlight. Herschel saw a blur. Later astronomers saw a galaxy. Modern astronomy sees a cosmic monument built from mergers, dark matter, hot gas, and time. And that is why the story of this giant feels so powerful. The universe did not announce it all at once. It allowed humanity to notice a faint mark in the sky, then spend generations learning what that mark truly meant. A smudge became a galaxy became a central giant, and the central giant became evidence of how the universe builds its largest structures. But understanding where IC is and how it was recognized is only the beginning. The next question is deeper. How does a galaxy actually grow into something so immense? What happens when galaxies meet, when gravity pulls them together, when stars are scattered, and when smaller systems disappear into a larger one? To answer that, we have to watch gravity at work. not as a force that acts in a moment, but as a patient architect shaping the universe across billions of years. To understand how a galaxy like this becomes so immense, we have to stop thinking of galaxies as finished objects. They are not statues placed in space, silent and unchanging. They are moving systems shaped by gravity, environment, and time. A galaxy may look calm in a telescope, especially when seen from more than 1 billion light-years away, but that calm can be deceptive. What appears smooth and quiet today may be the settled result of countless ancient disruptions. Galaxies do not simply exist beside one another forever. They move through space. They feel the pull of nearby matter. They pass close to neighbours, distort, stretch, and sometimes merge. On human timescales, this motion is too slow to notice. A galaxy collision can take hundreds of millions of years, longer than entire branches of life have existed on Earth. But to the universe, that is not a sudden event. It is part of the ordinary rhythm of structure forming. When we hear the word collision, we imagine impact. We picture objects striking each other, breaking apart and scattering debris. But galactic collisions are stranger than that. Stars inside galaxies are separated by such enormous distances that when two galaxies pass through each other, individual stars almost never hit. The real violence does not come from stars crashing together. It comes from gravity. Gravity reaches across the whole encounter. It pulls on billions of stars at once. It bends their paths, stretches their orbits, and draws long streams of light out into space. A spiral galaxy that once looked graceful can become warped and unbalanced. Its arms can stretch into tidal tails, enormous ribbons of stars pulled outward by the force of the encounter. Gas clouds can be compressed, and when gas is squeezed strongly enough, new stars may ignite in bright bursts. The galaxies pass through one another, separate, slow down and return, bound by gravity until their separate identities begin to disappear. If we could watch this process in fast motion, it would not look like a simple explosion. It would look more like a dance slowly turning into a storm. Two galaxies approach from the dark, each carrying its own structure and motion. Their shapes begin to bend before they even touch. Stars are pulled into arcs, gas streams inward, the centres swing past one another, separate and fall back again. With every pass, the old order weakens. The original shapes become harder to recognise. After enough time, the two systems settle into one larger galaxy. This is one of the main ways giant elliptical galaxies are built. A spiral galaxy depends on order. Its stars move through a flattened disk, its arms curve around the centre, and its gas and dust help form new stars along those arms. But repeated mergers disturb that delicate structure. They scatter stars into wider, more random orbits. They consume or heat the gas. They erase the spiral pattern. What remains is often smoother, rounder, and older looking, a galaxy that no longer resembles a bright wheel but a vast cloud of stars. Now imagine that happening not once but many times. A central galaxy inside a rich cluster lives in a very different environment from a galaxy in a quiet group. It sits near the bottom of a deep gravitational well. Around it are many other galaxies, moving through the cluster, interacting with one another and slowly changing their paths. Over billions of years, some of those galaxies drift inward. Some are torn apart before they reach the centre, their stars scattered into the cluster like dust shaken from an old tapestry. Others sink deeper and eventually merge with the central giant itself. This slow process is sometimes called galactic cannibalism. The phrase sounds dramatic, but the real process is not a quick devouring. It is gradual, patient, and almost geological. On Earth, mountains rise because continents push against one another over immense stretches of time. Rivers carve valleys grain by grain. shorelines change with waves that seem small in the moment, but become powerful through repetition. A giant galaxy grows in a similar way. It is built by motions that are too slow for us to witness directly, but too persistent to ignore. IC1101 became enormous because it lived in the right kind of cosmic environment. At the centre of Abell 2029, it occupied a place where gravity could keep delivering material. Smaller galaxies that wandered too close could lose stars to its outer halo. Larger encounters could add entire populations of stars to its body. Over time, each merger made the galaxy larger, smoother, and more dominant. The final result is not the product of one spectacular event. It is the sum of many ancient encounters, layered together until the original histories are almost impossible to separate. This is why the outer regions of IC1101 are so important. The faint halo surrounding a giant galaxy is not just decoration, it is evidence. Many of the stars in that halo may have been born somewhere else, inside smaller galaxies that no longer exist as separate systems. Their parent galaxies were stretched, stripped, and absorbed, but the stars remained. They became part of the larger glow. In this way, the halo's like the margin of an old book, filled with traces of earlier stories. The main text may belong to the giant galaxy, but the edges still carry marks from the systems it gathered into itself. The smooth shape of the galaxy tells another part of the story. A spiral galaxy carries visible memory of rotation and structure. Its arms show where gas and dust still trace organized motion. A giant elliptical looks different because its history has been mixed. Repeated mergers scatter stars into many directions, so the galaxy becomes less like a flat disk and more like a swollen cloud. It may appear peaceful, but that peace is the aftermath of disorder. The calm glow is what remains after gravity has had time to settle the debris. Inside the galaxy, the stars themselves can preserve clues. Some are old and red, shining with the quiet light of earlier cosmic eras. Others may have formed during bursts triggered by mergers when gas was forced inward and compressed. Their motions can reveal whether they were born in place or added later. Their chemical makeup can hint at the environments where they first formed. To astronomers, this is like reading layers of stone in a cliff. One layer speaks of an ancient sea, another speaks of volcanic ash, another marks a long-vanished river. In the same way, the stars inside a giant galaxy can reveal the stages of its construction. But mergers do not only build the outer galaxy, they also change the centre. Most large galaxies contain supermassive black holes at their hearts. When two galaxies merge, their central black holes are carried into the same new system. Over time, they sink toward the centre and begin orbiting one another. This pair can disturb the surrounding stars in a powerful way. Stars that pass too close can be flung outward, like stones thrown from a sling. The black holes lose energy and move closer together, while the stars are pushed away into wider orbits. Over repeated mergers, this process can carve out the central region of a galaxy. Instead of becoming denser and brighter toward the middle, the core can appear depleted, as if something has swept stars from the centre. IC1101 is famous for having an enormous depleted core, and that feature may be one of the clearest signs of its violent past. The galaxy grew by adding stars from other systems, but its heart may have been hollowed by the black holes those systems brought with them. There is something strange and almost poetic about that. A galaxy can grow larger while its centre becomes emptier. It can gain mass through mergers while losing stars from its core. Creation and removal become part of the same process. Gravity gathers on one scale and scatters on another. The universe does not build with simple rules. It builds through balance, exchange, and consequence. Gas adds another layer to the story. In younger or gas-rich galaxies, mergers can drive gas inward and trigger waves of star formation. For a time, the galaxy may blaze with new blue stars, But in the largest cluster-centered galaxies, much of the gas has already been used, heated, or prevented from cooling. The surrounding cluster is filled with extremely hot gas, and the central black hole can release energy that keeps this gas from collapsing into stars. Over time, the galaxy becomes older in appearance. It still contains immense mass, but it no longer builds new stars at the rate it once might have. That is why giant ellipticals often feel like ancient empires. Their most active age of construction lies far in the past. Their greatness remains, but it is carried in old stars and vast halos rather than in bright new spiral arms. They are not dead, but they are quieter. They glow with the memory of earlier growth. So when we look at IC1101, we're not simply looking at one galaxy. We're looking at the result of a long chain of events. We're seeing stars born in different places, gathered into one structure. We are seeing the aftermath of mergers that destroyed older forms and created a larger one. We are seeing the influence of black holes that may have carved out the centre. We are seeing the power of a cluster environment that kept feeding the giant over billions of years. And that changes the meaning of its size. IC1101 is not merely big. Its scale is not a single measurement, but a history written across space. Every faint extension of its halo hints at something that came before. Every smooth curve suggests a past encounter that erased sharper structure. Every missing star in its core may point to a gravitational dance between black holes hidden long ago. From a distance, the galaxy looks quiet, but that quiet is deceptive. Inside it is the memory of swallowed galaxies, scattered stars, vanished spiral arms, and black holes moving through darkness. The violence has cooled, the debris has settled, the structure has become smooth. What remains is the survivor. And once we understand that IC becomes more than a cosmic giant, it becomes a history of the universe written in light, a monument to what gravity can do when it is given enough time to turn many galaxies into one. At the centre of a galaxy like IC1101, behind the vast glow of old stars and the enormous halo surrounding it, there is something even more extreme than the galaxy itself: a black hole. Not a small black hole formed from the death of a single star, but a supermassive one, the kind that lives in the hearts of large galaxies. Our own Milky Way has one. It is called Sagittarius A star, and it contains about 4 million times the mass of the Sun. That already sounds almost impossible. 4 million suns compressed into a region of darkness at the centre of our galaxy. But in the largest galaxies, the scale rises again. The central black hole may not contain millions of solar masses, but billions. In a giant galaxy like this, astronomers suspect that the central black hole could belong to an even rarer class, an ultramassive black hole. These are objects so enormous that ordinary language begins to feel too small. They're not just dark points at the centres of galaxies. They're gravitational anchors powerful enough to influence the structure around them across tremendous distances. To understand what that means, it helps to begin with what a black hole actually is. A black hole is not a cosmic vacuum cleaner, pulling in everything across space. From far away, it behaves like any other object with mass. If the Sun could somehow become a black hole without changing its mass, Earth would not suddenly be sucked inward. It would continue orbiting as before, though without sunlight, life would quickly end. The true strangeness of a black hole begins close to it, near the boundary called the event horizon. The event horizon is the point of no return. Cross it, and escape becomes impossible. Not for a spacecraft, not for a particle, not even for light. It is not a surface made of material. It is a boundary in space and time, a place where gravity has become so intense that all paths lead inward. Beyond that edge, the universe as we understand it falls silent. For a stellar black hole, that boundary may be only a few kilometers across. For a supermassive black hole, it can be larger than the orbit of planets. And for an ultramassive black hole, the the event horizon could stretch across a region so vast that it becomes difficult to imagine as a single object. A darkness that large is not merely hidden at the centre of a galaxy. It becomes part of the galaxy's architecture. But black holes are known not because we see them directly, but because we see what they do. At the centre of a galaxy, stars move under the influence of gravity. Gas heats up, accelerates, and sometimes glows. Jets of energy can blast outward from the region around the black hole, not from inside the event horizon, but from the violent environment just outside it. Matter falling inward can form a spinning disk, where friction, magnetic fields, and gravity turn gas into one of the most energetic engines in the universe. The black hole itself remains dark, but the space around it can become extraordinarily bright. In IC 1101, the most important clue may not be brightness, but absence. The galaxy has one of the largest known depleted cores. That means the central region contains fewer stars than astronomers would expect if the galaxy's light kept increasing smoothly toward the middle. Instead, the heart of the galaxy looks strangely hollowed out. Not empty, but missing part of the dense stellar population that should be there. This missing light tells a story. When two large galaxies merge, each one may bring its own supermassive black hole. Over time, those black holes sink toward the centre of the newly formed galaxy. They do not immediately become one. First, they orbit each other, forming a pair locked in a slow gravitational dance. Around them are stars moving through the central region. Some of those stars pass close to the black hole pair, and when they do, they can be flung outward at enormous speeds. The black holes lose energy and move closer together. The stars gain energy and are thrown into wider orbits, or sometimes pushed out of the core entirely. Over millions of years, and through repeated mergers, this process can carve out the central region of a galaxy. The galaxy grows larger through the merger, but its heart becomes more depleted. This is one of the most surprising ideas in the story of IC 1101. The same process that builds the galaxy may also hollow it out. Gravity gathers stars into the giant's outer body, while black holes scatter stars from its centre. Addition and subtraction happen together. The universe builds a larger structure while removing light from its core. That is why the depleted centre of that galaxy is so important. It is not just a detail, it is evidence of history. It suggests that this galaxy has experienced major mergers in the past, perhaps many of them. Each merger may have brought in another central black hole. Each black hole pairing may have pushed more stars outward. What remains today is a core so vast that it can be compared to the scale of entire smaller galaxies. And yet the black hole does more than reshape stars near the centre. It can also influence the gas surrounding the galaxy. In massive galaxy clusters, the space between galaxies is not truly empty. It is filled with extremely hot gas, spread so thinly that it would seem almost like nothing by everyday standards, but so vast in total volume that it contains an enormous amount of matter. This gas can shine in X-rays, revealing the deep gravitational environment of the cluster. In theory, if that gas cooled enough, it could fall inward and form new stars. But giant central galaxies often do not form stars as rapidly as they could. One reason is feedback from the central black hole. When gas falls toward the black hole, some of the energy released can be sent back into the surrounding environment. Powerful jets may shoot outward, pushing into the hot gas and inflating huge cavities, like bubbles blown into an invisible ocean. These outbursts heat and stir the gas, making it harder for the gas to cool and collapse into new stars. In this way, the black hole becomes a kind of cosmic thermostat. Too much gas cooling would create waves of new star formation. Too much heating would keep the galaxy quiet. Across long periods of time, the black hole and its environment enter a strange balance. The galaxy feeds the black hole, and the black hole changes the galaxy's future. This relationship is one of the deepest connections in modern astronomy. Large galaxies tend to host large central black holes. The growth of the galaxy and the growth of the black hole appear to be linked. As galaxies merge, their stars and dark matter combine, but their central black holes also move inward and eventually merge. The galaxy becomes more massive, and the black hole becomes more massive with it. Then the black hole releases energy that affects how much new star formation can continue. It is not a simple relationship of ruler and kingdom. It is more like a long negotiation. The galaxy supplies matter. The black hole returns energy. The galaxy grows through mergers. The black hole reshapes the center. One influences the other over time spans so long that no human lifetime can truly feel them. This makes the center of IC1101 one of the most fascinating parts of the entire galaxy. Its vast outer halo shows growth. Its smooth shape shows the aftermath of mergers. But its depleted core shows something more hidden: the invisible violence of black holes working in darkness. We do not need to see the black holes directly to know they mattered. Their effects are written in the missing stars. There is something almost poetic about that. A galaxy famous for its immense light may carry its deepest secret in a place where light is absent. Its outer regions glow with the stars it has gathered, while its center bears the mark of stars thrown away. The brightest giant in the cluster may have been shaped by one of the darkest objects in the universe. And that contrast is part of what makes IC so powerful to imagine. It is not only a giant cloud of stars, it is a system of opposites: light and darkness, growth and loss, silence and violence, a vast halo built from absorbed galaxies, and a hollowed core carved by black holes. The galaxy is not just sitting in space, it is the visible result of invisible forces working for billions of years. Once we understand this, IC1101 becomes more than a question of size. It becomes a reminder that the universe builds its grandest structures through relationships we are only beginning to understand. Stars reveal gravity. Darkness shapes light. Black holes, though hidden, can decide the fate of galaxies larger than imagination. And still, even this is not the largest frame. The black hole explains the heart of IC1101. The mergers explain much of its growth. But the reason such a galaxy could become so large in the first place lies in the environment around it. It does not live alone. It sits inside a massive galaxy cluster, surrounded by hot gas, dark matter, and countless gravitational interactions. To understand the giant fully, we have to step back again and look at the cosmic architecture that made its growth possible. To understand why it could become so large, we have to step back from the galaxy itself. No giant galaxy grows in complete isolation. A galaxy may look alone in a telescope image surrounded by darkness, but that darkness can be misleading. Around the largest galaxies are environments shaped by gravity on a scale far beyond a single stellar system. There are neighbouring galaxies, invisible dark matter, enormous reservoirs of hot gas, and larger patterns of structure that reach across the universe like a hidden framework. IC1101 is not simply a giant sitting in empty space. It lives near the centre of Abell 2029, a massive galaxy cluster more than 1 billion light-years from Earth. And that location is one of the main reasons it became so immense. A galaxy cluster is one of the largest structures in the universe held together by gravity. It is not just a random crowd of galaxies seen in the same direction. It is a real system, bound by mass. Hundreds or even thousands of galaxies can move inside a cluster, each following long paths shaped by the gravity of the whole. Between them is hot gas, spread so thinly that it would seem almost empty by human standards, yet so vast in total volume that it contains more ordinary matter than all the cluster's stars combined. Surrounding and binding everything is dark matter, an invisible substance we cannot see directly, but whose gravity shapes the cluster like the foundation beneath a city. This means that when we look at a cluster, The bright galaxies are only the visible part of the structure. They are like lamps shining inside a much larger building. The walls, beams, and weight of that building are mostly hidden. Dark matter forms the deep gravitational framework. Hot gas fills the spaces between galaxies like an atmosphere stretched across millions of light years. The galaxies are what our eyes notice first, but the cluster itself is the true machine. At the center of that machine, gravity is strongest. This is why the position of IC 1101 matters so much. It lies where the cluster's gravitational pull has had the most time and opportunity to gather material. Imagine a vast basin after a storm. Water does not remain evenly spread across the slopes. It runs downward, joining other streams, carrying soil, stones, and debris toward the lowest point. A galaxy cluster works in a similar way, though unimaginably slower. Over billions of years, galaxies move through the cluster, interact with one another, lose energy, and drift inward. The center becomes the place where matter accumulates. A central galaxy does not swallow everything around it in one dramatic act. The process is quieter and more patient. Smaller galaxies can pass too close and lose their outer stars. Those stars are added to the faint halo surrounding the central giant. Other galaxies may sink deeper and eventually merge with it. Some are stretched into long streams before they disappear as separate objects. Each event adds a little more mass, a little more light, and a little more history. This is why cluster-centered galaxies can become so different from galaxies like the Milky Way. Our galaxy lives in a smaller and quieter neighborhood. It has companions, and one day it will merge with Andromeda, but it does not sit at the heart of a rich galaxy cluster. It is not surrounded by hundreds or thousands of galaxies moving through the same deep gravitational well. Its environment gives it a different future. The Milky Way may grow, but it is not being fed by the universe in the same way. IC, by contrast, occupies one of the privileged positions in cosmic structure. It lives near the bottom of the valley. Gravity keeps bringing material toward the center of Abell 2029, and over cosmic time, that location becomes an advantage. The central giant is not just old, it is well placed. Its size is not only the result of age, but of address. That idea is important because the universe does not build all galaxies equally. In quiet regions, a galaxy can preserve its spiral arms for billions of years. Its gas can continue forming stars. Its structure can remain delicate, like a wheel turning in the dark. But in crowded environments, gravity is more disruptive. Galaxies pass near one another more often. Their outer stars can be stripped away. Their gas can be heated or removed. Their shapes can be blurred by mergers. Elegance gives way to scale. This is one reason giant elliptical galaxies often appear old and smooth. They're not usually rich in bright blue young stars. They shine mostly with older stars, giving them a calmer, redder glow. Their most active period of star formation may have happened long ago. What remains is the result of growth by assembly, not the fresh construction of a spiral galaxy still building many new stars in its arms. But the cluster does more than supply galaxies for mergers. It also surrounds the central giant with hot gas. This gas can reach tens of millions of degrees, hot enough to glow in X-rays. At first, that may sound like a perfect source of material for future stars. After all, stars form from gas, but gas must cool and collapse before it can become stars. In a massive cluster, much of the gas is too hot and too spread out to form stars easily. The central black hole can make this even more complicated. As gas falls toward it, the black hole's surrounding region can release enormous energy back into the cluster. Jets can push outward, stirring and heating the gas, keeping much of it from cooling too quickly. In that way, the galaxy sits in the middle of a vast reservoir of material, but much of that material cannot simply settle down and form new suns. It is like an old kingdom surrounded by fields that are too scorched, too disturbed or too distant to harvest. This helps explain why a galaxy can be enormous and yet quiet. IC1 101 contains a vast population of old stars, but it is not a brilliant factory of new ones in the way some younger galaxies are. Its growth has largely come through the gathering of existing stars and matter, not through endless waves of fresh star birth. It is magnificent, but ancient, massive, but restrained, bright, but not youthful. The environment around it also connects it to something even larger than the cluster. Galaxy clusters are part of the cosmic web, the vast architecture of the universe. On the larger scales, matter is not spread evenly. Galaxies gather along enormous filaments, while immense voids open between them. The pattern looks almost organic, like roots spreading through soil or rivers branching across a landscape. But it was shaped by gravity, acting on tiny differences in density that existed in the early universe. Slightly denser regions pulled in more matter. Over billions of years, those regions grew into galaxies, groups, clusters, and filaments. In this picture, Abell 2029 is not an isolated island. It is one knot in a much greater web. IC 1101 is the central giant within that knot, the place where matter has gathered most strongly inside its local environment. Its story is therefore part of a larger cosmic story, the universe building upward from small beginnings, turning tiny early variations into the vast structures we see today. That is what makes the galaxy so humbling. Its size is not an accident. It is the visible result of cosmic architecture. First came the early universe, almost smooth, but not perfectly smooth. Then gravity amplified its small differences. Matter flowed into denser regions. Galaxies formed. Clusters assembled. At the centers of some clusters, giant galaxies grew by absorbing smaller systems and gathering stars stripped from their surroundings. It is one of the most extreme examples of that long process. And still, the final scene looks almost still. From our distance, IC 1101 appears silent, calm, and unmoving. Abell 2029 seems like a frozen arrangement of galaxies, but that stillness is an illusion created by our short lives. The cluster is active on timescales too large to feel. Galaxies are moving through it. Gas is swirling and heating. Stars are drifting in the space between galaxies. Dark matter is holding the whole structure together. The giant at the center is not frozen. It is simply changing at the pace of the universe. This is the great difference between human time and cosmic time. To us, 1,000,000 years feels almost eternal. To a galaxy cluster, it is a moment. To us, a galaxy looks like a permanent jewel in the sky. To the universe, it is a structure still being shaped, still responding to gravity, still carrying the marks of everything that came before it. So when we ask why IC is so large, the answer is not just that it had enough time to grow. Time matters, but time alone is not enough. It also needed the right environment. It needed a massive cluster, a deep gravitational well, many neighbouring galaxies, a vast halo of dark matter, hot gas, repeated mergers, and a central position where gravity could keep delivering material across billions of years. A giant galaxy is not only a product of age, it is a product of place, and place in the universe can decide destiny. In a quiet region, a galaxy may remain graceful and spiral-shaped. In the heart of a rich cluster, it may become something broader, older, and far more massive. The universe gives different neighbourhoods different futures. Some galaxies become delicate wheels of stars, some become irregular fragments, a few become titanic central giants. IC 1101 belongs to that final category. It is not just one galaxy among many. It is the luminous centre of a much larger gravitational system, a galaxy shaped by its cluster as much as by its own stars. Its enormous size is the result of many forces working together, each one adding to the story. Gravity pulling inward, galaxies merging, stars being stripped away, gas being heated, dark matter shaping the invisible basin around it. By now, the pattern becomes clear. The biggest galaxy is not explained by a single measurement or a single event. It is explained by a chain of causes stretching across cosmic history. The galaxy is huge because it grew in a crowded place. It grew because gravity had time. It grew because smaller systems fell in. It grew because the cluster around it acted like a deep well, gathering matter into the center. But there is one more step in this journey, and it may be the most humbling of all. Even a galaxy as immense as IC1101 is not permanent. It had a beginning. It has changed across time, and far in the future, it too will fade. To understand the biggest galaxies fully, we have to look not only at how the universe builds them, but at what time will eventually do to them. That may be the strangest thought in the entire story. When we hear words like giant, colossal, or largest, it is easy to imagine something almost eternal, as if size itself could protect an object from time. But the universe does not spare its largest creations. It simply takes longer to change them. IC1101 may look timeless from our point of view. It lies more than 1 billion light-years away, glowing at the center of a massive galaxy cluster, surrounded by faint halos of stars, hot gas, and dark matter. Its light has traveled across space for longer than complex life has existed on land. By the time that light reaches our telescopes, it feels less like a picture and more like a message from an ancient chapter of the universe. But the galaxy itself is still changing. The stars inside it are aging. The brightest, most massive stars have short lives by cosmic standards, burning through their fuel quickly and dying in explosions or collapsing into compact remnants. In giant elliptical galaxies, many of those young blue stars are already gone. What remains is mostly an older population of stars glowing with a quieter, redder light. This is why galaxies like IC1101 often feel ancient. They are not blazing with fresh star formation the way some younger spiral galaxies are. They shine with the accumulated light of stars born long ago. That does not mean they are dead. A galaxy is not alive in the human sense, and it does not die in a single moment. It fades slowly. Its gas becomes harder to cool. Its supply of fresh star-forming material becomes limited, heated, or disturbed. New stars may still form in small numbers, but the great age of construction is largely behind it. The galaxy continues to glow, but more like an old city at night than a sunrise over new land. Over billions and then trillions of years, this fading becomes more dramatic. Stars like the Sun eventually swell, shed their outer layers, and leave behind white dwarfs, hot stellar cores that slowly cool in the dark. Larger stars leave neutron stars or black holes. Smaller red dwarf stars can burn for far longer than the current age of the universe, shining patiently for trillions of years. In the distant future, those long-lived stars may become some of the final steady lights in galaxies like this. So the future of IC is not sudden destruction. It is a long dimming. Imagine a vast library at night, with lamps burning above millions of shelves. One by one, over periods too long to feel, the lamps begin to fade. The building remains, the shelves remain, the silence deepens. Something like that happens to an old galaxy. Its structure may persist for unimaginable spans of time, but the light that makes it visible slowly thins, and the universe around it is changing too. The expansion of the universe is not slowing down as once expected. It is accelerating, driven by what astronomers call dark energy, a name for a mystery more than a complete explanation. On smaller scales, gravity can still hold galaxies and clusters together. Abell 2029 will not simply be pulled apart by cosmic expansion, because its own gravity binds it as a local system. But beyond such bound islands, distant galaxies and clusters will continue to recede. Over enough time, more and more of the universe will move beyond the reach of observation. That future is difficult to picture. The universe will not become smaller, it will become lonelier. The great cosmic web, which today stretches across the observable universe in filaments and clusters, will fade from view for any observers living in the far future. Distant structures will slip beyond the cosmic horizon. Their light will no longer be able to cross the widening space between them and whatever remains of local galaxies. In that future, a giant like IC1101 would still belong to its cluster, but the larger universe around it would seem increasingly empty. The night would lose its distant islands. The architecture of the cosmos would become harder to see. A civilization born in that far age might look out and find far fewer clues that the universe was ever filled with galaxies beyond its own gravitational neighbourhood. This makes our time special. Not special because we are central, but because we live in an era when the universe is still bright enough to be read. Galaxies still shine, clusters are still visible, the cosmic web can still be mapped, ancient light from distant objects can still reach us. When we observe IC1101, we are seeing not only a place, but a time. Its light left that galaxy more than 1 billion years ago, crossing the expanding universe until it arrived at a small planet orbiting an ordinary star. There is something humbling about that journey. The photons entering a telescope today began their voyage before humans existed, before our cities, before our languages, before the first eyes like ours ever looked up and wondered about the sky. They travelled through darkness while Earth changed beneath them. Continents shifted, life evolved, species vanished. Eventually, a civilization appeared with instruments sensitive enough to catch that ancient light and ask what it meant. And what it meant was this. Somewhere far away, the universe had built a giant, a galaxy larger than the Milky Way, grown at the centre of a cluster shaped by mergers, surrounded by a faint halo of stars and marked by a core that may have been carved by black holes. It was not just an object. It was a record of cosmic history. Its size told of accumulation. Its smoothness told of collisions. Its darkness at the centre told of forces hidden from sight. Its place in Abell 2029 told of the importance of environment, because even the largest galaxies are shaped by where they live. But the deepest lesson may be that even this is temporary. Gravity builds, time transforms, stars shine and fade, black holes grow and may, on unimaginable timescales, slowly lose energy through processes at the edge of modern physics. The universe is not a museum of finished monuments. It is a story still unfolding, and every structure inside it is only one chapter. That does not make IC1101 less impressive, it makes it more extraordinary. Because we are seeing it during a luminous age, a time when galaxies still reveal themselves against the dark. We can study its light, measure its distance, trace its halo, and infer the violent history that made it. We can understand that its stars were gathered across billions of years, that its core carries the mark of black hole mergers, and that its future will be shaped by the slow fading of the universe itself. The scale is almost impossible to hold all at once. On one side there is a galaxy so vast that its outer light dissolves into the cluster around it. On the other there is Earth, a small rocky world where life learned to look outward. The contrast should make us feel small, and it does, but it should also make us feel connected to something immense. The atoms in our bodies were formed in stars. The light we study was born in galaxies. The same universe that builds giants also produces minds capable of wondering about them. So when we think of it, we should not picture only a number, or a title, or a record for the biggest galaxy. Picture a long, silent empire of stars, built from the remains of smaller galaxies, shaped by gravity and darkness, glowing at the center of a cluster more than 1 billion light-years away. Picture it aging slowly while the universe expands around it. Picture its stars dimming across trillions of years, its great central darkness lingering after most lights have gone out. And then picture this. From a world so small it vanishes beside even an ordinary star, we have learned that such a thing exists. That may be the most astonishing scale of all. Not only the size of the galaxy, but the reach of understanding. SC1101 is bigger than imagination can comfortably hold, but the human mind can still follow its story. From a faint blur in a telescope to a cosmic titan, from ancient mergers to a distant fading future, it shows us a universe larger, older, darker, and more beautiful than anything our ancestors could have known. The giant remains out there in the deep, quiet and distant, but no longer unknown. And once something that vast becomes known, the universe itself feels larger than before. If you liked the video, don't forget to leave a like and subscribe. It makes a huge difference and helps the channel grow.